Hello everybody. Today I will be showing how to find the value of root of cos x by first principle method. First principle method, according to the first principle method, it means if limitation of h tends to 0, then it is given as f of x plus h minus f of x divided by h. So in this we would be substituting the value of f of x with root of cos x. So how it would be turn out, let's see. limitation of limitation of h tends to 0, root of cos of x plus h whole root minus cos of x divided by h. So this is a value now we have to find out, but we see that we can't put the value of h as 0 simultaneously because it would become indefinite. So we have to solve it and remove this h so that we can substitute the value of h 0 and we can get the uh, derivative of this from first principle. So let's see now. Limitation of h tends to 0. Now in most of the situations when there is root, so you should rationalize or remove the root. So like here in the numerator it is root, we would multiplicate or multiply it with plus of this, like this, into plus of, so it turns out cos of x plus h root plus cos of x. Okay, now after this, if we multiply in the numerator, then we have to automatically multiply denominator also. So in denominator also we would the multiply with same value, which is root of cos of x plus h into plus root of cos of x. Now we know that the formula, if a minus b into a plus b, it turns out a square minus b square. So it would become cos of x plus h minus cos of x and divided by h into root of cos of x plus h plus root of cos of x. Okay, now after this we know the formula of cos x minus b. It is minus 2 sine x plus y by 2 into sine x minus y by 2. I will write it here. We know that cos x minus cos y is equal to minus 2 sine x plus y by 2 into sine x minus y by 2. Okay, now we would substitute the value. Limitation of h tends to 0, minus 2 of sine x plus h plus x by 2 into sine of x plus h minus x by 2, and whole divided by same value h into root of cos of x plus h plus root of cos of x. Okay, now simplifying it, limit of h tends to 0, minus 2, that would become 2x now, so 2x by 2 would become x plus h by 2. Oh, sorry, we have to write sine x plus h by 2 into sine of, now here the x and x would become x and x will get cancelled, so it only remains h by 2, now divided by h into cos of x plus h plus root of cos of x. Okay, now after this here we know that if a limitation of x sine x by x is equal to 1, so here means we have sine h by 2, so in the numerator we have 2, we would just divide it in the h so that it becomes h by 2, and sine h by 2 by h by 2 would become 1, so it would become 1, and it would be easy for us to simplify. Sine x plus h by 2 into sine, it would be minus here, sorry, sine h by 2, now divided by, here sine h by 2 divided by h by 2, and here here only root of cos of x plus h plus cos of x root of x, okay. Now this whole thing will become 1. So now what would be our solution? Limitation of h tends to 0 minus sine x of h by 2 divided by this, okay, now x cos x plus h plus root of cos of x. Now because this becomes 0, now we are only having this much of thing to solve. Now here we can put the value of h as 0 because it would not become indefinite, so we would be getting value by putting h putting h is equal to 0, we get what we get. Here we get minus sine of x, because 0 by 2 and means anything is divided by 0, it becomes 0. Sine x, now root of cos of x plus root of cos of x, it would become minus sine x divided by 2 root cos of x, okay. Now here means we can leave the answer till here, or we can just multiplicate or rationalize it more, and it becomes more simple, like minus of sine of x divided by 2 into root of cos of x into root of cos of x, and in numerator also we have to do this same. Now it becomes minus sine of x into cos of x divided by 2 cos of x, and this thing we can write here. I would write the answer because I'm not having the space here. It would become minus of tan of x, as we know that sin x by cos x equal to tan x. Now tan x into root of cos of x divided by 2, this would become our answer, final answer. So this was our solution for finding the value of root of cos of x from the first principle method. We found the derivative. Thank you.